Uh, so in this case of the bank road, we choose axes like the horizontal and vertical, and you resolve the normal reaction in and the friction force. Okay, so do the same thing. Bobby, I can see the screen.
Yes, sir.
Okay, so see in this case, this is the bank road, the B part. So here we choose the axis as horizontal and vertical. That's why this normal reaction was split into n cos theta and n sin theta, and similar friction force as F cos theta and F sin theta. The reason for that is this acceleration is in the horizontal direction, not along the plane perpendicular to the plane, it's along the horizontal direction. The centripetal acceleration is in the horizontal direction. That's why you have to choose horizontal direction as the x-axis. So now you have to write the equations. Uh,
So 1 minute, I'll be back. I'll go to the washroom and come.
yeah. So only three forces, right? Mg, normal reaction, and friction force. Let me take the first one, F1. So it's up the plane, and that friction force is making an angle theta with the horizontal. Okay. So in the vertical direction, it's n cos theta. Put mg, and centripetal acceleration is towards the center. So the force in the center towards the center is minus F1. Okay, okay. Mg has to be split, no? No. Okay, n cos theta, n sin theta. N sin theta minus F1 equal to m into AC, that is m into v square by r. Okay, so and F1 is what? Optimum speed, right? So optimum in the sense the maximum speed. So F1 is mu to n. There's only one mu and n sin theta. Go to the right hand side. So how many unknowns are there? N and then theta is given. P is unknown. Yeah, n and b are the unknowns, right? So if I divide, I'll get sin theta minus v equal to v square by r divided by G. Okay, so from this I'll get 950 minus mu is how much? R is 300 G. Okay, so this will give the optimum speed. Sin 15 minus 0.2 300 G square root. Not what I have drawn. If he's saying that in the first situation for optimum speed, there should be no wear and tear, no? So you have to put F1 equal to 0. There is no friction force. Right? And here I made a mistake. This is by cos theta. The force which is acting downwards, it's what? Down the plane. It's N angle is 90 minus theta square mg sin theta. Normal reaction. Friction force. mg sin theta downwards. Normal reaction is perpendicular. So mg sin theta. Are you getting it? Bhavya?
Yes, sir.
See, he's saying this. Okay, when the car is going at a low speed, the direction of friction force is 1, right? Okay, and he's saying this friction force should be 0 for there to be no wear and tear. Okay, so actually in this equation, you just put F1 equal to 0. Okay, so from that you get V square as tan 15 to R into G.
Okay.
Okay, you just have to divide n cos theta first equation by second equation. So you get tan theta or 2 by 1. Daksh,
Yes, sir.
are you getting it? This is equation 1 and this is equation 2. Okay, so 2 by 1 will give this one, this result with F1 equal to 0. Daksh, getting it?
Yes, sir.
So from that we get V square equal to tan 15 to R into G, where R is 300 meters. That's what he has done here. This is mu is equal to 0. From that we get V naught as Rg into tan 15 square root. Okay, so the second case is moving in high speed, so that the friction force will be in the two direction. So to write the equation, the friction force. Right. So write the equation of the second case. So what is the horizontal direction equation? Okay, the vertical one is n. What happened? Okay, I have this equation. I need this figure. Friction force F2 is down the plane. Okay, so again, n cos theta is mg, and then horizontal direction, the inward force is F2 cos theta plus n sin theta equal to m v square by r. Are the equations correct? N cos theta equal to mg, and this horizontal direction, n sin theta inverse F2 cos theta equal to v square by r. So now we have to find F2 is mu into n, right?
Yes, sir.
Kavya, are you doing it?
Yes, sir.
So again, you have to divide. N will cancel. So F2 n will cancel cos theta plus n. So what is the question we have to find? Maximum permissible speed. Not F2. So it's Rg into mu plus tan theta square root. Rg into, make a mistake. Or this there is a mistake in the equation. No, mg plus F2 sin theta. Right. Okay. So that you can make it minus mu n sin theta. Theta 1 will imply mu plus n. So is it clear?
Yes, sir.
Bhavya, mic is off.
Yes, sir, it's clear.
Okay, I made that mistake. I left out that F2 vertical component. Okay, so we bring this F2 on this side. So equation 1 and 2 are this one. The one on the top, equation 1 and equation 2. Okay, you divide those two. So you get v square by rg equal to v plus tan theta by 1 minus mu tan theta. Theta is known, mu is known, r is known, g is known. From this you can find the velocity. This is the maximum speed. Right. After that it starts scaling. Okay, so tan theta is there. Plus mu tan theta. Okay, theta is increasing, the tan theta is increasing. No, numerator increase and the denominator. Okay, one thing. So when see the value of theta is in first quadrant, no.
Yeah, so
Okay, so
it will
when
be was
theta increases, tan theta will increase, right?
yeah,
And numerator, if you consider this as numerator by denominator, numerator will increase or decrease? Increase. Denominator will
increase,
denominator
decrease.
decrease. So
Or
numerator by denominator will increase, right?
yeah, yeah,
Okay, so that means v is going to increase. The maximum speed with which the car will move without slipping will increase. Okay, so that's why the banking is required. If you have theta more, then the maximum speed with which the car can move will increase. Got it?
Yes, sir.
So this banking of the road is helping you to move with high speed without slipping. Right. There is one more interesting thing to observe. The theta cannot be too high. What will happen if theta is too high?
The object will lose contact with the surface,
If theta
or
is too
it'll
high,
topple over. It'll topple over.
toppling is one problem. Fine. The direction of friction force will change because you try to slide down because of the mass, weight. There are two forces. No, one is the component of mass, which is uh, down the plane, and then the friction force. Okay, I'll come back to you if you don't understand. Let us do this problem. Two blocks, even into connected by a string, slide in the plane. Theta is 45. Coefficient sliding friction in the block, and plane is 0.4. And 2 and plane is 0.2. That will come up. This is very simple, no?
Yeah.
So mu1 is 0.4. This is mu1 equal to 0.4. Mu2 is 0.2. Theta is 45 degrees. Okay, m1 is 1 kg. m2 is 2 kg. And basically, you have to draw the free body diagram. There will be tension, which is pulling this block up, and tension here will be pulling the block down. Tension will always pull. Okay, so for M1 the tension is pulling it down. For M2 the tension is pulling it up. Is it clear? Bhavya?
Yes, sir.
Bhavya?
Yeah.
Tension will always pull. Okay, so
I can't.
and there is a common acceleration. So I think you can solve this on your own. I don't.
Yeah. Yeah.
Okay. Okay, block is addressed in a rough inclined plane. Horizontal force is applied. Find the force of normal reaction. Okay, you have to find normal reaction. Find and friction can friction be zero? If yes, when? Assume friction not zero. Find limiting value. Okay, so the normal reaction is this way, and the weight is downwards. You're scribbling or what?
No, sir.
Okay.
Okay, I'm scribbling. Right. Okay, only three forces. No, friction force is there. Friction force will direction depends. It depends on the net force. Find the force of normal reaction. Okay. Okay. For the normal reaction thing, we don't have to consider direction of friction force. It does not matter. Either this way or that way. Normal reaction, the things contribute to normal reaction are the mg and applied force, right? Yes or no?
Yeah.
For that, what is this angle?
Theta.
Theta.
What is this angle?
Theta.
180 no, theta, never mind. Okay.
Alternate
Theta.
angles.
Theta.
Okay, so the normal reaction here
Yeah,
is
theta, theta.
mg cos theta plus f sin theta. Correct?
Yeah.
Can the force of friction be zero? Okay, the vertical along the plane, the forces are F cos theta upwards and downwards it's mg sin theta. Right? So when these two forces are equal, the friction force is zero because net force is zero. Is that clear? F
Yeah.
force
Yes.
push it up, mg sin theta will pull it down. Normal reaction is perpendicular to the plane, that will not contribute. So friction force can be zero when this condition is satisfied. Assuming that friction force is not zero, find the magnitude and direction of the limiting value. Okay, so there are two cases. One, the F is large. In that case, the block will try to move up, the friction force will be downwards. Second case is F is not large. In that case, the block will try to move down and the friction force will be up. Understanding?
Yeah.
Yes.
Two cases, so there will be two answers. Let me see the solution. Okay, there are a few more problems in this thing. Do it as homework. If you're not able to, I'll do it next time. Okay.
Okay, sir.
So can you
Okay, this is the one we got. Normal reaction is mg cos theta plus f sin theta. Mg cos theta plus f sin theta, that's correct. And friction force can be zero. That friction force is mg tan theta. When f equal to mg tan theta. F is mg tan theta. Correct, no? From this one.
Yes, sir.
Limiting friction mu minus mg cos theta plus f sin theta. Friction force. Okay. So both mg cos. Okay, he's assuming the friction force is upwards. See, when you're assuming friction force is upwards, the total downward force is mg cos theta plus f sin theta, no? Right? The bracket should not be here. It's mu mg cos theta plus f sin theta. Fine. Okay. I have put this sheet also. You can also look at this one. And if you have any doubts, consult next time. He's assuming the friction force is upwards.